Hey guys, I'm Jose and welcome to this new tutorial in Unity. So we're going to start just looking at how to create an array and a collection of, or basically how to instance a prefab in a series inside Unity, right? So I'm going to start with a simple scene with just a few elements like a first-person controller, a plane, and a directional light, right? So let's start creating quickly a cube that is going to be our prefab. So I'm going to create a new prefab that is going to be called brick. Let's call this cube um, brick cube, right? And let's drag this cube into the prefab, and there we go. We can see that this guy, we could just place it somewhere here. Um, so there we go. Just making sure that this object is somewhere. So this is our brick, right? So this is gonna be our prefab. We can basically get rid of that now and just place as many as we want, right? So it's a prefab that has been described there. So the second thing I want to do is just create an empty game object that I'm gonna call the brick wall, right? Because we're gonna do a brick wall made out of several bricks, right? And for this one, we're gonna just create a new JavaScript called tutorial 04, and we're going to drag this tutorial 4 to the brick wall, right? So this brick wall is going to be an empty game object, and if we just go ahead and edit this script, we could start kind of doing the scripting for this game object. So the first thing we're going to do in the script is describe the brick element that is going to be a game object type, right? So if we save that, we could specify the brick being the game object we're going to be working with. So that's the first variable that we want to do. And what we want to do is something called instantiate, right? So instantiate requires three pieces of information: a game object, a vector, and a quaternion, right? So let's create those and see how we actually instantiate an object in the scene, right? So vec3d or vector3 position, it's from the type, or sorry, I mean processing mode. Variable vector3 equals a new vector3 0, 0, 0, right? So that's the way we're describing a vector of position. And a variable rotation from the type quaternion. And this one, it's a bit trickier because a quaternion, it's a quaternion is just something perhaps difficult to grasp, but it's, imagine that it's an arrow that has an orientation as well. It's not only an arrow, but it also has a kind of a secondary arrow showing which is up for the arrow itself, right? So basically, we need to specify a quaternion, and we're not gonna go into quaternions just yet. We're gonna just describe a quaternion of identity. Um, that is gonna just give us a kind of a default orientation dot identity, right? Identity, right? Um, and that should be enough. That should be like the default orientation of the prefab. Let's see if we're not having any errors right now. We're fine, and we're ready to just call the function instantiate. And we're going to instantiate what? We're going to instantiate the brick in the position with the rotation, right? So these are the three ingredients that we need, and we should see now. Let's see if we don't have any errors, that we can just walk around and then we can find that we have the cube that we just created, right? I forgot to turn on shadows, so I'm gonna just do that quickly. So shadows are hard shadows should be fine. So if we go and see now, we can see that we have our cube there. So that's looking pretty good. I mean, we're just through the script, we're kind of bringing one of these guys into the scene, right? So that's this instantiate is actually working pretty well. But we could do this in a series, right? So like, for instance, we could use a for loop structure that it's a way of repeating a piece of code several times. So we're gonna do a for loop saying var I equals 0, I smaller than 10, I plus plus. And in this way, we're gonna make all this chunk of code to be repeated 10 times, right? That's what the for loop is doing. It's like whatever it's inside here, it's gonna be repeated 10 times. And the problem is that if we repeat this 10 times, we're gonna just be able to basically repeat 10 elements in the same place, right? So that's not what we want. What we really want is just use this variable I that we create in the loop, right, to separate the elements. So we can separate them in x, for instance. So we could say I here, and I'm going to just multiply it by 2 just to make sure that we have enough distance between elements. So let's see what we get now. And you can see that we have placed 10 bricks in a line, right? So, okay, that sounds okay. So these 2 maybe wasn't needed, and we could say, well, what about just put them closer to each other? So that's good. That's not too exciting, really. Like, let's see how we can actually make this kind of a wall. A brick wall, in a way, it's just thinking that we would want to kind of have so many, like a row of bricks, but also columns of grid. So it's a kind of a grid of bricks. And for that, we can actually do a little bit of, counting. So I'm going to create some variables, right? I'm going to create a variable called columns. That's going to be an integer type. And we're going to say columns equals maybe 10. And variable rows. Also an integer type equals 5. Just start small, and then we're gonna also create a variable count x that is gonna be again integer equals 0 and count y, right? So these variables are gonna help me count as I'm creating this brick wall and position the elements wherever we want. So what we want to do is just count from the multiplication of columns and rows. So if we think that we have so many columns, 10 columns or 10 columns and then 5 rows, if we multiply these 2 numbers, that would give us the total number of elements, right? So you could say here columns times rows, right? So now we're basically gonna do 50 elements. But I need to do a bit of calculations with the count in order to kind of build some sort of typewriting machine. In a way, what I want to do is just like create 10 bricks in this direction, and when I get to 10, I go back to 0, but then in y I go +1, and I start counting again in the second row, right? So I'm going to say every time I do that, like the instancing, I'm going to say counter x plus plus. That says it means +1. And I'm going to also say if counter x equals columns, right? What happens? Count x equals 0 and count y plus plus, right? So if I reach 10, count x goes back to 0 and count y gets 1, right? So these variables are going to be counting through my wall. And instead of using I now, I could use here count x. And because the set, or basically the y-axis is the height, we're going to use here count y. And let's see if this works. And if it works, oh, there we go. So yeah, it's working pretty well. We are having kind of a brick or a series of blocks here, right? Um, but it seems that our first elements are kind of just kind of intersecting with the ground plane. So we need to just put a little bit of extra. So +1 to y, like so. Even from the beginning, it's gonna be a little bit kind of lifted, right? So now we have them like that, right? And that's pretty straightforward. Let's do something a bit more interesting, like this brick here. The prefab, we could actually make it a rigid body, right? So in a way, when we bring it into the scene, we can make it calculate some physics, right? So if we go to component physics and rigid body, just by having that object selected and that prefab selected, we could add a rigid body component to that object, right? So if we play this now, you see that our kind of brick wall calculates, and all the bricks are kind of falling on top of each other, and there seems to be a little bit of kind of they're still kind of balancing around. This is just because the rigid body has certain kind of mass and certain parameters that you can actually change if you want to get different results. But let's distort a little bit the calculation so we can actually make some interesting effects, right? So this variable, the first thing we should know is that it's a private variable because we're using it for counting. We don't want to expose it for the user, right? So you see that a private variable in my brick wall doesn't appear, and you see how it disappeared just because I kind of, so columns and rows is something that I can just expose, but counting, it's in order for the script to work, I shouldn't be able to expose. So if I want to remove that, I just use this private line here. So what else? Maybe I want to just say, well, what about that every other row, right? We add some value to it. Let's say we displace them. So, like, how do you do odd and even, right? So we could say variable extra from the type float equals 0, right? And if count y modulo 2 equals 0, right? What this line is saying is that if the counter in y, the one that it's kind of determining the rows, this symbol is a modulo, or the remainder, right? So we're gonna divide this element by 2, and if there's no remainder out of that operation, so basically if it's 0, this part of the code is gonna get executed, right? So that means that every other row it's gonna get this piece of code, and this piece of code is gonna be extra equals 0.5, right? Something like that. Else extra equals 0, right? So now if we actually put x plus extra, let's see what we get here, and yeah, and you see that now basically the next row, it's in a way has an offset from the beginning. It's not kind of as before. We could see that a bit better if we remove the rigid body object, or remove component here. and just look at the script now, and you see that like the first row, it's not at the same, it has some offset from the one below, right? So that's a good way of just like I'm gonna just bring that back actually, because I thought it's nice to have that physics in there. So rigid body object, there we go. And but at the same time, my brick wall could use maybe 20 elements and maybe 10 rows. So let's see what we get here. So you see that I have my bricks and I have a little bit of collision going on, and yeah, they kind of simulate and calculate, and that's fine. I can just go up, and my brick wall is standing there and it's looking pretty good, right? Um, so we could add some rotation to these elements. So for instance, if we create a game object or a variable, a new object that is from the type game object, right? We could say that whenever we instantiate the element, that instantiated object is this variable, right? So that would allow us to do an operation like new object dot transform dot rotate. I could say maybe we can basically say anything really here. So let's create a variable to rotate all these guys slightly different, right? So oh, we could rotate them by I, comma 0, comma 0, right? So the first element is not gonna be rotated, but as we're moving along in the in the loop, we're just gonna be rotating them more and more, right? Um, so just to have some fun to see what we can actually get out of this calculation, and you see that basically, well, I wasn't expecting that, but probably because of the if the objects are instantiated and colliding with each other, they explode, right? So they basically are in a position in which they cannot, that collision, it's not gonna calculate properly, so they are gonna bounce with each other. So just that's something to bear in mind. So we could see that problem if we actually remove again the rigid body component, right? So, and if we see the orientation, uh I was actually planning on rotating them in Y, really, but we got something pretty cool there. Um, so you see that how I'm rotating these elements. Let's do that I in the Y direction, so like this. Remember just to save the script every time before going into Unity. So this is what I was actually planning on doing. Whereas there's a rotation of objects, and I'm trying to build a brick wall like that. You could also create a few variables that could actually make this a little bit kind of nicer. So for instance, you could determine also here a multiplier times multiplier in X and times multiplier in Y, right? So if we create these variables now, public ones like these ones, you will be able to kind of determine the distance between the bricks, right? So I'm going to use multiplier X and Y here, and they're going to be from a type float, just to give the tool a little bit, and this should be 1 right now. So if you go from 0 to 1 or even beyond 1 to 2, you should be able to determine the distance between bricks, right? That could become really handy. So let's go to brick wall and let's put maybe distance in of 3. Let's see what we get. And is Is that working? Are we getting a bigger, like a longer wall? What if we put 10? Well, it seems that it's working, but it's doing something a bit strange, which is kind of just multiplying the right, the extra, right? So we're gonna just put the multiplier with a parenthesis here, count x times multiple x, and count y times multiple y. So let's see now. So you see that now it works much better. And yeah, definitely this 10 was too much, right? So we could say 3. And we start to get a bit of what I was thinking of. So we have this kind of wall. They're kind of too far away from each other, really, but like, oops, you can see what we were going for. And I could just bring back once more the physics to see if we get the exploding bricks again, or if we just, right? So you can do a pretty fun game trying to just make these bricks stay still, and in a way do variations of the wall, and where you can try to make these bricks just stand, right? Um, so yeah, just trying different options. And, and that's it for this one. I'm just gonna try it one more time just to see. But you see, we're creating a big mess, really. But yeah, you can have a lot of fun with physics and arrays here, just by determining the way they start and the rotations, and how to position them in the screen. So that's it for this tutorial, and I'll see you guys soon.